My name is Chris West, and this is the Collectionbot designed for CS480. The overall goal of the Collectionbot was to collect objects, in this case markers, and place them in a receptacle on the side of the robot. To this end, unique hardware was added to the Turtlebot: an arm and a different camera. The arm for the project was provided by Tross and Robotics. The Phantom X pincher arm uses a grasper to manipulate and move objects around itself. To manipulate the arm, a topic called the Simple Arm Server was provided. This topic takes a point and a coordinate frame, calculates the joint angles required to move the arm, and determines if it is able to move the arm to that point. This takes away the need for reverse kinematics, however slows down the program greatly. I used an Asus Xeon camera instead of the Turtlebot's normal Kinect camera. This allowed this downward view of the workspace instead of the crosswise view normally seen by the Kinect. And here's the Collectionbot in action. The first attempts to move its grippers around a marker, close the grippers, and move the pen to a predetermined location over the cup. After a moment, it then releases the marker and moves it back to a safe location so that it can continue to collect markers. This is a simulation of the Collectionbot generated by RViz. The red dot in the simulation and in the camera represents the target for the arm. In this case, the target actually is the red sticker on the marker, but could easily be a different target set up by the controller node. The mover node then takes this target and transforms it so it's in a frame that the Simple Arm Server can understand and move the arm to. The transforms had to be calculated very carefully since there was not a lot of wiggle room between the pen and the size of the gripper. One of the biggest issues of the project was developing fine control of the arm. Markers aren't very well balanced, and even the slightest nudge will upset them, so there was a lot of this. The solution to this was to add a middle step, aiming the arm at the pen and then having it move forward. It still utilized the Simple Arm Server, but it was less likely to knock over the pen since it wasn't swinging around as far out. I'm showing this one in real time to show how slow the processes actually are when determining where the arm can move to. Using a computer that was more powerful than the netbooks probably would have sped up this process greatly, but unfortunately it was not possible at this time. Theoretically, the Collectionbot would continue to pick up pens until there are none left, but because of how slow the process is, I only ever showed one being picked up. If I had more time to work on this project, I probably would have added moving and sorting functionality to the Collectionbot. It would be able to move between workstations and sort different objects into different cups and increase its usefulness.